In this case, one picture is worth a lot more than 1,000 words. It's probably worth about 79,999,998 words. That's because it took me 3 days to draw this single picture for your viewing pleasure. So sit back, relax, and enjoy the fruits of my labor as I explain how nuclear bombs are really made. As we all know, World War II was a very terrible time for humanity. The world was plunged into darkness as two teams competed to see who could create the deadliest weapon known to man, which they would then use to blow up their enemies' cities. The United States ended up winning the race, dropping 2 atomic bombs on Japan, forcing them to surrender and bringing an end to the war. But today, many people don't actually know how these weapons were made. In fact, some people believe that the bombings were faked and that they never really happened at all. But this isn't true, and today 235, also known as U-235, is the key ingredient in making a nuclear bomb. This is because when you split one of these atoms, it releases a tremendous amount of energy. In fact, splitting one of these atoms releases approximately 200 million times more energy than splitting one atom of regular uranium. Just to put this into perspective, if you were to take a paper clip and convert all of its mass into energy, it would be able to power the average household for about 1 hour. However, just 1 gram of U-235 could power the average household for about 36,000 years. The problem was the US didn't have any uranium-235 when the war started. In fact, at the time, no country on Earth had any uranium-235. However, there was plenty of uranium-238 available, which is what all the uranium naturally contains. So the question became, can uranium-238 be converted into uranium-235? The answer, thankfully, was yes. It just required an incredibly complex process involving several steps. Step no. 1. Find some uranium. The United States didn't have any uranium mines of its own, so it purchased most of its supply from Canada and the Belgian Congo. Once the ore was acquired, it was shipped to Oak Ridge, Tennessee, where the first step of the process would take place. This step involved milling the uranium ore and converting it into a fine yellow powder called uranium tetrafluoride. Step number 2, turn it into gas. Next, the uranium tetrafluoride was transported to another facility in Oak Ridge, where it was heated to 450 degrees Celsius, causing it to turn into a gas. This made it much easier to handle and prepare for the next step, which was to separate the uranium-235 from the uranium-238. Step 3, separate the isotopes. To do this, the gaseous uranium was sent to a facility in Clinton, Missouri, where it went through a process called gaseous diffusion. Basically, the gaseous uranium was forced through a series of membranes, which allowed the lighter uranium-235 to pass through, while the heavier uranium-238 was left behind. This process was repeated over and over again until the uranium-235 was concentrated enough to be used in a nuclear bomb. Step no. 4. Make some fuel rods. After the uranium-235 was separated, it still wasn't in a form that could actually be used in a nuclear bomb, so it was sent to a facility in Chicago where it was turned into long, thin rods. These rods were then placed inside long metal tubes, which were sealed at both ends. This created the fuel rods that would eventually be placed inside the reactor at Hanford, Washington. And now we're at step no. 5. Produce plutonium-239. For this to happen, the uranium-238 that was left over from the previous step needed to be sent to the Hanford facility. Here, it would go through a process called neutron bombardment. Basically, the uranium-238 was bombarded with neutrons, which caused it to absorb a neutron and eventually decay into plutonium-239. This was done by placing the uranium-238 inside long metal tubes filled with water. The water would slow down the neutrons produced by the nuclear reaction, allowing more of the uranium-238 to absorb a neutron and eventually decay into plutonium-239. The water would also help absorb the radiation produced by the nuclear reaction, allowing the process to continue without damaging the equipment. Step number 6, extract the plutonium. Once the uranium-238 had decayed into plutonium-239, it needed to be extracted from the fuel rods. This was done by first removing the fuel rods from the reactor and then dissolving them in a strong acid. The plutonium-239 was then extracted from the acid using a process called solvent extraction. This process involved using a special organic solvent that would dissolve the plutonium-239 but not the other materials present. The solvent was then stripped of the plutonium-239 by adding a solution of nitric acid. This created a concentrated solution of plutonium-239 that could be used to make a nuclear bomb. Step number 7, turn it into 20 little gray boxers. At this point, the concentrated solution of plutonium-239 was sent to Los Alamos, New Mexico, where it would be turned into the actual device that would cause the destruction. To do this, the solution was first evaporated to dryness, leaving behind a black tar-like substance. The substance was then dissolved in a small amount of nitric acid and purified by removing any impurities. The purified plutonium-239 was then converted into a form that could be machined into the shape needed for the device. This was done by first dissolving the plutonium-239 in a solution of hydrochloric acid, which created a salt called plutonium. The plutonium trichloride was then converted into plutonium dioxide. By reacting it with oxygen, the plutonium dioxide was then pressed into a slug shape and machined into the exact shape and dimensions needed for the device. The final step was to coat the plutonium-239 slug with a thin layer of metal called hafnium. This was done to prevent the plutonium-239 from coming into contact with air, which could cause it to corrode. Congratulations! You just helped build an atomic bomb. Now let's drop it on some Japanese people. Okay? But seriously, once the weapons were built, they were then transported to the Pacific island of Tinian. From here, they were loaded onto 2 different airplanes. The first plane was a B-29 bomber called the Enola Gay. This was the plane that would drop the first atomic bomb on Hiroshima. The second plane was a B-29 bomber called the This was the plane that would drop the second atomic bomb on Nagasaki. On August 6, 1945, the Enola Gay took off from Tinian and headed towards Hiroshima. Around 8 o'clock in the morning, the pilot of the Enola Gay released the atomic bomb, which began its descent towards Hiroshima. At 8:15 a.m., the atomic bomb exploded over Hiroshima, instantly killing an estimated 80,000 people. 3 days later, the boxcar took off from Tinian and headed towards Nagasaki. On August 9th, around 6:20 a.m., the pilot of the boxcar released the atomic bomb, which began its descent towards Nagasaki at 6:22 a.m. The atomic bomb exploded over Nagasaki, instantly killing an estimated 40,000 people. The two atomic bombs dropped on Hiroshima and Nagasaki forced Japan to surrender, ending World War II. Today, there are approximately 13,000 nuclear weapons in existence. Hopefully, the people who have their hands on these weapons know exactly how dangerous they are and will never use them. Now, check out why you shouldn't swim in Lake Erie or click this other video instead. But seriously, why don't you click this video? It's so interesting. You'll be a better person after clicking it. Just click it. Come on. Please click it.